All right, continuing with example number 3, we're going to do the absolute value of 3x minus 4 is less than or equal to 11. And again, it could also just be less than, not also equal to. Okay, so this one, we're looking at this, but that looks like these guys. So that means one equation. So this is how we do this. We start with this guy, change his sign. These signs have to go in the same direction as they are right now. Then put our absolute value term in the middle without absolute value bars. Do our sign again, but do not change the direction it goes. Okay, and then our positive one. So we're getting both our positive and negative possibilities in there. Now this one, we're going to work from the inside out. Okay, so, but we do it exactly as if we have this equation, and then as if we have this equation, okay? But we can do it all at once. So the first thing I need to do is get this 3x all by itself. So that means I want to add 4 here. But if I add 4 here, sometimes computers drive me nuts. Okay, if I add 4 here, then I have to add 4 on this side, and I have to add 4 on this side. So now I have negative 7 is less than or equal to 3x, which is less than or equal to 15. Now I have to get the x by itself. So to do that, I need to divide the 3x by 3. But if I do that on one side, I have to, or in one area, I have to do it in every area. Excuse me. So here on the left side, I just have negative 7/3. And so then I'll put less than or equal to. In the middle here, all I have is x. And then on the right side, 15 divided by 5 is by 3 is 5. Now let's go ahead and graph this. This, remember, is algebraic notation. It's what you're always going to get, but that's not the way I'm looking for the answers. I'm looking for graph, and I'm looking for interval notation. And this one will have interval notation because this is an inequality, okay? Meaning it's got inequality signs, greater than or less than, which means we're going to have a range of numbers. So let's graph this, okay? Put my number line, arrows on both sides. I know on one end is going to be, or in one place is going to be 5, and the other place is going to be negative 7/3, so they have to go that way relationally. And I know it's going to be brackets because of the equal to, and I know that my x is in the middle of these, so I know my brackets are going to go this way, which means I just need to put a great big huge thick line right here in between these, and this is all I want to see. Okay, now we can double check. Let's say, just to be on the safe side, let's say x was 6. So if I put 6 in there, is 6 between negative 7/3 and 5? In other words, greater than negative 7/3? Well, it is greater than negative 7/3, but it is not less than 5. So I know 6 out here won't work. 7 won't work. 8 won't work. Okay, none of that'll work. So going the other way, I can check the same thing by saying, how about negative 6? Okay, is negative 6 greater than, and I know that negative 7/3, remember, is thirds, I'm getting ahead of myself, is negative 2 1/3. So is negative 6 less than negative 2 1/3? It is, greater than, because x is here in the middle. So is it greater than? it is not. So it can't be at the ends. So this is my graph. That's my answer for my graph. And then this is my interval notation. Okay? Now, there are a few, and remember, there can be no interval notation if our original sign is just an equals. No interval notation. Can't be. Okay? All right. So, few things you have to know about this. So let's do example number 4. Okay? So if I have 3a plus, the absolute value of 3a plus 2 plus 4 equals 15. Before I can decide whether I'm going to do 2 or 1 equation based on the sign right here, in this case equal sign, I have to get one absolute value term all by itself on one side or the other side. So that means in this case, I'm going to have to move this guy first. So that does not change my absolute value portion yet. And that would give me 11. 15 minus 4 is 11. Now I have one absolute value term on one side of the equal sign all by itself. And so I can go ahead and decide, am I going to do 2 or 1 equation? Well, equals means 2 equations. So I'm going to go ahead and do that. 3a plus 2 equals 11, and 3a plus 2 equals negative 11. Okay, equals negative 11. Okay, so now I just do each of these. So first I'm going to subtract 2 and then divide by 3. That gives me a equals 3. And then I'm going to subtract 2 here, and that gives me negative 13, and divide by 3 gives me negative 13 thirds. And so my answer is a equals negative 13 thirds or 3. Now remember, there can be no interval notation on this one because it's an equal sign, but I could graph it actually. If I were to ask you to graph this, this is what it would look like. A point here and a point here, one labeled negative 13 thirds and the other one labeled 3. That's it. So again, remember, you have to start with one absolute value term on one side or the other side of the equal sign before you can determine whether you're going to do 1 or 2 equations. Let's do another example. So this would be 5, I believe. Okay, so 4r minus 1, the absolute value, equals 3r plus 5. Now, I have one absolute value term on one side, so I don't really care what's on the other side. So, and based on this sign means I'm going to do 2 equations. So the first one I just write down exactly as it is and drop all the absolute value bars. The second one, I write the absolute value term on the left side exactly like it is, dropping the bars, and then equals. And remember, this is going to be negative on this side, but I got to be careful. It's got to be negative to the whole thing. So make sure to put the whole thing in parentheses so you can distribute that negative carefully. Now I just need to get my r's on both sides. So I'm going to subtract the 3r from both sides so I can keep my r term positive, and that'll give me r. And then I'm going to add 1 to both sides, and so I get this. And then this first thing I need to do is distribute my negative. Again, I'm going to add the 3r so I can keep it positive. Only this time I've got 7r on this side. And now I need to add 1 to both sides, so that gives me negative 4. And now divide both sides by 7, gives me negative 4/7. And so that's my final answer. R equals negative 4/7 or 6. Again, please write it like this, not like the book does. And one more time, if I did ask you to graph this, just a dot here and a dot here, I don't even care where, as long as they're on the correct side of each other, and I can see them both. Okay? All right, now a couple other things we still need to think about and look at. Okay? So, number 6. What if I had the absolute value of x plus 2 is less than negative 5? Okay? So, first I need to move this 2 over. So that gives me the absolute value of negative x is less than negative 7. Now, normally I would be thinking I'm going to do one equation based on this sign, okay? Which would be positive 7 less than x, which is less than negative 7. But, let's think about this. Remember the definition of absolute value? The distance a number is from 0 on the number line, and distance cannot be negative. So what this is asking is whatever x is going to be less than negative 7. That means this is not possible. Think about it. Okay. And one more. Absolute value of 1/4 x minus 3. Minus 3 is greater than, I'll just do greater than 0. Now normally, let me do it this way, based on this sign we would be doing two equations, but I can't get a negative 0. There is no such thing because one side would be negative, right? So that means I just need to do one equation. Okay, this is an equation. It's got a denominator, so basically my LCM equals 4, just like we've been doing in a few units ago. So 4 times 1/4x minus 4 times 3 is greater than 4 times 0. These cross cancel. That gives me x minus 12 is greater than 0. Add 12 to both sides, and I get this. Now let's graph this first, because it's always easier to do the interval notation after we've graphed it. Then I look at this, I say, what are things that x could be? Could it be 10? 10 is greater than 12. No, that's not true. Can't be 10. How about 9? No, 9 isn't greater than 12. How about 8? No, 8 isn't greater than 12. So it means I'm not going left. And my sign here is just greater than. It's not greater than or equal to. So it means a parenthesis, and we're going in this direction forever. Okay, with an arrow. And then from this, I'm just going to, so interval notation always has 5 things in it. It's got a parenthesis or bracket on each end, and they don't have to be the same. They have to match what's going on with the number next to them. It has as far left, so left end point, as far left as your x can be, in this case 12, and then a right end point as far right as your x can be, which in this case is positive infinity, and then the comma between it showing it's everything between. So there you go. Have fun.